This is 8.1, adding and subtracting polynomials. We're first going to talk a little bit about identifying them by degree and number of terms before we look at adding and subtracting them. So we'll start here with what's called a constant term. It's 12. It's in standard form, it would just be 12. The degree of this is actually 0 degree, because if I were to add a variable, the power on the variable would have to be 0 for this to remain equal to 12, because we know that x to the 0 is 1. 12 times 1 is still equal to 12. So degree is 0. Name from degree is just 0th degree polynomial or constant polynomial. Number of terms is 1, and name from terms is monomial. Now, within the class of polynomials, which means many terms, terms are separated by plus or minus signs. A monomial is considered also a polynomial, so it's special single term that's part of the class of polynomials. Second one here, we have 8 plus 7x. To write it in standard form, we're going to write it from highest power term to lowest power term. Since there is an unwritten 1 on the x, that is the highest power term, so it's 7x plus 8. This is of degree 1. We call it first degree. And this is made up of 2 terms, and so we would call it, just like a bicycle, a binomial. It has 2 terms. So binomial. Next one on here. Rearranging this in standard form, in descending order of exponents, it would go from y squared to 2y to minus 4. The degree would be second degree, because the highest power on that first term is second degree, second power. And number of terms, we have 3, and just like if you're riding a tricycle, it has 3 wheels. This has 3 terms, so it's called a trinomial. So we name monomials, binomials, and trinomials. Beyond that, we just call them polynomials, maybe a 4-term, 5-term, 6-term polynomial, but we don't have special names for them beyond the trinomial. So this next one has 4 terms. Change it around a little bit here. The first 2 terms are in order, but then the x would come next and the minus 1 last. Degree would be 3, so third degree. This one has 4 terms, and we just call it a polynomial. So anything beyond 3 terms, we just call it a polynomial. Once again, all of these above this are considered polynomials. The last one, we need to rearrange it so the x to the 4th term is first. This one is of degree 4, so we call it a 4th degree 3-term trinomial. So that's identifying polynomials by degree and by number of terms. Let's practice a little bit here. So first one, 5x. Not written, but there is a 1 as the power on the x. So this is first degree. This 3x to the 7th is 7th degree. Of course, the constant term 4 is 0 degree or 0 degree polynomial. And this one, we can see that there are 2 variables. And when we have 2 different variables on one term, we add the 2 powers. So 2 plus 3 is 5. Therefore, this is a 5th degree. So let's write that down. 2 plus 3 gives me my degree. So you add all the powers on the different variables in that single term. Now, when you have multiple terms in there, you would look to the single term that has the highest sum of the powers on the variables. So, adding and subtracting, we've talked quite quite a bit, actually a little bit so far, about adding, subtracting polynomials using algebra tiles. We've talked about like terms. You'll notice here that x squared, those are like terms. So we can just add the 3 plus 5, which is 8, and then attach that like term, x squared. So it's like asking, if we were drawing pictures, we'd have 3 big squares plus 5 more big squares gives us 8 big squares of size x squared. Same principle applies even when we have something other than an x squared, an x, or a unit. Here we have like terms, x cubed y are the like terms. There's an unwritten 1 in front of this one. So we add the 4 plus 1. That gives us 5. So this equals 5. And then just attach the x cubed y. A lot of students want to add the powers on the x and the y's, but we don't. We do that. Those are like terms. We just recopy it. It's only when we're multiplying x cubed times x cubed, or y times y, that we would add the powers to get x to the 6th, y to the 2nd. Only if this were multiplication right here would we do that. So because it's addition, we just add the numbers in front of the like terms and then copy the like term down. Now here, what I like to do with these, when you have a trinomial plus a trinomial, is maybe identify the like terms. You could also still draw pictures of algebra tiles if you'd like, but here I have 6x squared. We have a 6x and a negative 9x, which add up to be negative 3x. And then we have here a 7 and a 1, which add up to equal 8. And the last one here we're adding, we have a whole bunch of different terms. We have a trinomial plus polynomial. Let's identify the terms that have a y cubed on it. Here we have one here. Also circle the sign with it. 3y cubed plus negative 6y cubed is negative 3y cubed. Here we have y squared here and a y squared here. 7 plus 2 is 9, so it's 9y squared. And then I have a 5y here and a 7y here. 5y and 7y give me 12y. And then finally I have right here just a negative 9. So that is completely simplified. We've added the polynomials according to their like terms. Subtracting, what's the difference? Well, noticing that these are like terms, this is also a 1 in front of it. We would take 4 minus 1, which is 3, and so this equals 3, and then copy down the like terms. A couple ways to think about this last one here. We have a polynomial minus a trinomial. We have to see this subtraction sign here applies to each of these terms. So we're subtracting each of those terms from their like terms if they exist over in this polynomial here. Some students will go ahead and just distribute the minus sign. It's like there's an unwritten 1 in front of these parentheses right here. And then it's essentially changing it into addition.
Kim Werner, please dial extension 1028. Kim Werner.
So let's rewrite this.
Extension 1028. Thank you.
Distributing the minus sign, it's minus 7m to the 3rd. The minus 1 times minus 9 will give me plus 9m. The minus 1 times positive 6 is negative 6. So just rewriting it. And now it's just like adding that we did up above in problem 2. So I don't see any other m to the 4th term, so I just copy down 2m to the 4th. I only see one m cubed term, so just copy it down. There's nothing else to add it to. M squared, same deal. I've got just one m squared term. I'm going to copy it down. And then here I have a negative 8m and a positive 9m, which equal negative 8 plus 9 is positive m. And then I have here a negative 7 and a negative 6. Adding those together gives me negative 13, and I'm done. So once again, I distributed the minus sign here, 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 and then treated it like addition as we did up here.